Our next lesson is called Solving Problems Day 2. Let's now find the solution set for an inequality and model the solution set graphically. So the previous lesson we did solving problems, but they were equations. Today we're going to concentrate on inequalities. We'll start with problem number 1. A checking account is set up with an initial balance of $9,400 and $800 is removed from the account at the end of each month for rent. No other transactions occur on the account. So part A says, write an inequality whose solutions are the months M in which the account balance is greater than $3,000. In set notation, write the solution set to your equation by identifying all of the solutions, which would really kind of be like your part B. Okay, so we want to know the months, okay, the number of months. It says, write an inequality whose solution are the months. So technically, if they tell us the variable, we don't need to write another let statement, but I am going to do that in your notes to make sure it's very clear what we are using. And it's important to notice that if they give you a variable, that's the variable that you must use. You cannot use a different variable. So we're going to say, let M equal the number of months. Okay, so our beginning balance, our initial balance was $9,400. Then we are removing, it said, money from the account at the end of each month. So $800 for every month. So we're going to subtract 800M. And then it says the account balance we want to be greater than $3,000. That's coming from our problem right there. So we're going to use the is greater than symbol with 3,000. So now we can start solving this just like we would solve an equation, just keeping in mind if we run into any multiplication or division by a negative number, we must flip the symbol. So we'll get rid of the 9,400 by subtracting it. Whatever we do to one side, we must do to the other. So we get negative 800M is greater than negative 6,400. So then we would divide both sides by negative 800. And we would get M. Now we divided by a negative. So this symbol has to be flipped to become is less than. And here we get 8. Okay. So it says in set notation, write the solution set to your equation by identifying all of the solutions. So you have two choices when it comes to this. We're talking about number of months. So it says M is less than 8, but we know we can't go into negative months. So one option would just be to list all your possible answers, okay, since it is only a set few. So we would do our squiggle brackets and we would list the numbers we can use. We can use 0, 1, 2, 3, 4, 5, 6, 7, and then I'm not going to list 8 because it said we had to be less than 8 months. So that's one option. Our second option would be to write it using an inequality like this. So you do M. Now, usually we do real, but it's specifically said here that it's months, full months. So that means a whole number has to be used. So we're going to do M is a whole number such that it's going to be greater than or equal to 0. We have to make sure we use M. And then that's got to be less than 8. Can't go over 8. So that would be your other option on how to write that using set notation. In problem 2, Chelsea has $45 to spend at the fair. She spends $20 on admission and $15 on the snacks. She wants to play a game that costs 65 cents per game. Write an inequality to find the maximum number of times X Chelsea can play the game. Using this inequality, determine the maximum number of times she can play the game. Okay, so first, write an inequality to find. Here we go. Find the maximum number of times X that she can play the game. Now again, they're defining the variable for you. You do not have to write it, but for note purposes, we want to be very clear here. Let X equals number of times Chelsea can play the game. Now again, If it wasn't picked for you, you would have to pick your variable and absolutely define it. Here, since they defined it for you, you don't technically need a let statement, but if you just always write one, then you know you're always safe. Okay, so if we go back to the problem, we know she's going to spend $20 in admission no matter what. Then she's spending $15 on snacks, so plus 15. And she's going to play a game that costs 65 cents per game. We just don't know how many games, how many times she can play that game. So that's going to be plus 0.65 cents, right, per each game. And she only has $45 to spend. So that's going to have to all stay less than or equal to $45. So now we go through our steps, no distributive, but we do have like terms here. So this would become 35 plus 0.65x is less than or equal to 45. We would get rid of our 35 by subtracting it from both sides. So we have 0.65x is less than or equal to 10. And then we would divide both sides by 0.65. No need to change the inequality symbol, so we would just get x is less than or equal. And when you divide this out on your calculator, you're going to get 15 and 5/13. Now, are you going to play 15 and 5/13 of a game? No. So we're going to have to make a smart decision about what we're going to say is the maximum number of times she can play. Do we go down to 15 or do we go down to 16? Well, since it's 15 and 5/13, it doesn't matter whether it was above halfway or not. 16 games is going to be too much. She's not going to have enough money for that. So we always have to round down in this situation, which means the total number she could play would be 15 games. So Chelsea can play at most 15 games. And that concludes our lesson on solving problems day 2.